In Fabric, trust is enforced before data reaches the ledger. Access control determines who may request an action. Endorsement policies define which organizations must approve it, and validation turns those rules into auditable enterprise governance. You've built the foundation: Fabric architecture, transaction flow, chain code, and data modeling. Now we shift from what business logic does to who can approve it, invoke it, and govern it across the network. A Fabric transaction is trusted because it passes through independent checks. The client identity must be allowed to call the Chaincode function. Required peers then simulate the proposal and add endorsements. Ordering places transactions into sequence, but it does not decide business correctness. During validation, Fabric checks the endorsement policy before committing. This separation matters in a shared ledger because no single organization can push unauthorized or unilateral changes. An endorsement policy defines whose approval is required before a transaction can be valid. Think of it as the business rule for signatures. A policy might require both org1 and org2, any one of several organizations or 3 out of 4. After endorsement, ordering simply places transactions into blocks. The actual policy check happens during validation, where missing or insufficient signatures cause the transaction to be marked invalid. Signature policies turn endorsement into governance. Rather than naming individual people, they usually name organizational identities, such as an org1 MSP peer or an org2 MSP peer. An OR rule keeps processing flexible by allowing any approved organization to endorse. An AND rule gives stronger joint control by requiring every named organization. Threshold rules like 2 of 3 balance resilience and oversight. A transaction is valid only when the collected signatures satisfy the policy. Unanimous approval may sound safest, but in enterprise networks it can create a veto point. Majority and threshold policies avoid that by requiring enough trusted parties, not every party. In Fabric, a rule like out of 2 of 3 means any 2 listed organizations can endorse successfully. The key is governance fit. Choose thresholds based on authority, risk, and accountability, so the network stays trustworthy without becoming operationally fragile. These are 2 different checkpoints. Lifecycle endorsement happens before the smart contract is used. It defines which organizations must approve a chain code definition, so one member cannot quietly change the version, sequence, or policy. Chain code endorsement happens later, when applications submit transaction proposals. It determines which peers must execute and sign before a ledger update can be valid. Governance first, transaction trust at runtime. Start by separating transaction types, because not every action needs the same approval. Then identify which organizations are truly accountable: legal, operations, compliance, regulators, or business owners. Convert that authority into Fabric patterns like and, or out of, such as 2 of 3. Finally, validate the policy with governance stakeholders, not just developers. A strong endorsement policy proves that the right parties approved the transaction, making validation meaningful, auditable, and aligned with real business responsibility. State-based endorsement moves Fabric beyond one policy for the whole chain code. A specific asset or private data key can carry its own validation rule, such as approval from one owner, multiple owners, or a custodian group. That rule is stored with the ledger state as a validation parameter. When a transaction updates that key, Fabric uses the key-level rule for validation, so high-risk or jointly owned assets can require stronger approval than ordinary records. With state-based endorsement, governance follows the asset, not just the chain code. When an asset is created, the manufacturer may be the required approver. When ownership changes, the owner's endorsement may become more important. If the asset enters a restricted or disputed state, a regulator or auditor can be required. This is especially useful for high-value or sensitive assets, including private data. The trade-off is complexity, so use it where lifecycle rules truly differ. Endorsement answers: do peers agree with this result? Chaincode authorization answers a different question. Is this client allowed to ask for it? Before changing state, the contract can read the caller's MSP ID, inspect certificate attributes, and verify roles or claims like approver or auditor. If a check fails, return a clear error immediately. The rule is simple: reject first, write later. so unauthorized requests never modify the ledger. RBAC and ABAC solve the same problem from different angles. RBAC asks, what role does this identity hold? An issuer or auditor receives permissions tied to that responsibility. ABAC asks, what certified facts are true about this identity? Department, region, clearance, or license status can drive finer decisions in Chaincode. Use trusted certificate authorities for attributes, and treat both models as governance policies that must be documented, tested, and reviewed. Treat Chaincode authorization as the last line of defense, not a trust exercise delegated to the client. Every sensitive path should confirm who is calling, what role or attributes they hold, and whether the requested action is allowed. Do this before reads that expose data, writes that change state, events that reveal information, or policy updates. Reusable helpers keep checks consistent, and careful logging supports audits without leaking secrets. Policy design is a balancing act. If one party can endorse alone, the network loses shared trust. If every transaction needs too many approvals, the system becomes slow and fragile. If roles are vague, teams hesitate or approve the wrong actions. And if technical rules do not match real governance, the blockchain only appears controlled. Good policies make accountability explicit, distribute authority appropriately, and keep security from overwhelming daily operations. The core idea is governance made enforceable. Endorsement policies decide whose approval is required. State-based endorsement protects specific assets, and Chaincode authorization controls who can act. Next, we connect these rules to real applications, using SDKs and gateway flows to submit transactions, gather endorsements, and integrate with enterprise systems.